Welcome back to the Getting Started with STSIM series. In this video, we will download the tutorial dataset, learn about working with folders, set output options, run a spatial simulation, and create maps of our results. To download the tutorial dataset, I'm going to navigate to www.apexrms.com, and on the main menu, I'm going to select Resources, Tutorials. I'm then going to scroll down to the third video, which is the tutorial we're currently working on, and here there's a link to download the dataset that was created in the previous tutorial and is the starting point for this tutorial. I'm going to click on it, and when the tutorial is done downloading, I'm going to select to show in the folder where it is located, and I'm going to right-click on that file and select Extract All, keeping the default location. Once that is extracted, I'm going to navigate into that folder, and what we have here is an SSIM file, which is a SynchroSim library containing both model inputs and outputs. And this is the library that we created in the previous tutorial. If I double-click on that library, it will open up SynchroSim, where we can begin making edits to the library. Now, the first thing I'm going to do in this library is create some folders so that I can organize my scenarios. I'm going to do this by right-clicking where it says Definitions and selecting New Folder. In this folder, I'm going to call Non-Spatial Simulation Scenarios. And for this tutorial, we're going to focus on looking at the scenarios with harvest. So I'm going to right-click on the No Timber Harvest scenario and select Delete. I'm going to be prompted to make sure that I'm sure to delete the scenario and click Yes. And I'm going to rename the existing scenario by right-clicking on it and selecting Rename. And I'm going to call it, just append the words non-spatial to the name of this scenario and click OK. And now to put it in the folder, I can simply hold down my left mouse button and drag it into the non-spatial simulation scenarios folder. Now I want to have a folder to put all of my spatial simulation scenarios, and to do that I'm going to right-click on Definitions again, select New Folder, and create a scenario or a folder called Spatial Simulation Scenarios, and select OK. And so what I'd like to do now is I'd like to take all of the inputs that we developed in the previous tutorial and make a copy of them and just modify a couple of things for running spatial simulations. And to do that, I can right-click on the scenario, select Copy, and then right-click in the Spatial Simulation Scenario folder and select Paste. And the first thing I'm going to do before modifying the scenario that I just copied is just rename it. And again, I can do that by right-clicking on it and selecting Rename. And instead of naming it non-spatial, I'm just going to select spatial. At this point, I want to remind you of what the model looks like that we're running. So this is a simple model of a forested landscape with three possible states: deciduous, mixed, and coniferous, alongside with three transitions: succession, fire, and harvest. Now, to make some changes to the scenario which I want to run spatially, I'm going to right-click on it and select Properties. And I'm going to go to the Run Control tab. And this is a scenario that we're running for 40 annual time steps and 100 Monte Carlo realizations. And on this tab, I'm now going to select to run the model spatially. The other change that I need to make is to define what kinds of outputs I would like to see for this scenario. But before doing that, I'm just going to briefly review some of the other inputs that we set. For example, in the previous tutorial, we defined these transition pathway diagrams that show the state classes and the transitions between them. And if you look at the previous tutorial, you'll learn how to assign probabilities and rates to those transitions. We also defined the initial conditions for the landscape, and when we were running non-spatially, we set up a hypothetical landscape with 1,000 hectares in size and 1,000 simulation cells. And in addition to that, we initialized our landscape to be 20% coniferous, 40% deciduous, and 40% mixed. Now, when we run spatially, we're not going to provide input maps in this tutorial, so the model will randomly assign each grid cell an initial value for state class and age based on this distribution. Another input we defined was how much timber harvest we want over time, and here we set the model to run with 20 hectares of timber harvest per year. Now, in this case, in the previous example, we didn't define explicitly what outputs we want over time. In this case, we're going to explicitly ask for state class tabular output every time step, transition tabular output every time step, and we're going to also ask for output maps or spatial output for state classes, transitions, and ages every time step. And we are now ready to run the model. To do so, I'm going to first save my library, and I can do so by either clicking on the Save button here or File Save All. And I'm going to then run the scenario, and I can right-click on it and select Run. Now that my scenario is complete, I can look at the same charts that we created in the previous scenario, in the previous tutorial. And so to do that, I double-click on the States and Transitions chart, and I'm just going to resize the window by clicking on Arrange All. And so here we have on the left the amount of area in each state class, and on the right the amount of area undergoing the different kinds of transitions. I would like to see how this scenario compares to the non-spatial scenario. And to do that, I can right-click on the non-spatial scenario and select Add to Results. And so in this example, we have almost identical results for the two scenarios, and this makes sense because the only thing I've changed is that I've requested essentially to generate maps of my outputs. Now, to view the output maps for the scenario that I just ran, I'm going to first remove the non-spatial scenario from results because we won't have output maps for that scenario that we ran in the previous tutorial. And to create a map, down here in the Scenario Manager window, I can click on the Maps tab. And the very left button is the button that I will click on to create a new map. And I'm going to call this map States and Ages. And click OK. And I'm going to click on the Basic node and select State Class and Age. And at the top here, I want to see the values for time step 0, 20, and 40. 0 representing our initial conditions, time step 20 halfway through our simulation, and time step 40 at the very end of our simulation. And I'm going to click Apply. And so what I see here is, along the top row, maps of the state class of each simulation cell for the first Monte Carlo realization of my simulation. And along the bottom, maps of the age of each cell for the first Monte Carlo realization. And what I can see is I'm starting out with coniferous forest in purple, mixed forest in aquamarine, and deciduous forest in yellow. And the redder colors in the age map represent older forest between 80 and 100 years of age. And the very dark blue colors represent very young forest, younger than 20 years of age. And you can see over time that there is less and less coniferous forest and less of the older forest as we move forward in time. Now here I can also make changes to my legend. For example, I could right-click on the legend for state classes and select Edit Legend. And I could select to use dark green for coniferous forest. And I could choose to use a brown for the mixed forest. And I can go back to the map and select Apply, and that automatically updates my legend to use the new colors. The other map that I'd like to show you is a map of the transitions that happen over time. But before I do that, one other thing I wanted to show you is that I can scroll through the iteration. So this is only the first Monte Carlo realization. If I click on the button, it will update it and show me the second Monte Carlo realization. And so one thing you'll notice is the way that the cells are assigned to different state classes and ages is quite random. And that's because we didn't provide a starting conditions map. We simply provided that starting distribution of state classes and ages that the model then uses. Now, to create a map of transitions, I go back to my scenario manager, the Maps tab, and click on the button to create a new map. And I'm going to call this map Transitions and select OK. And under Transitions, I'm going to show a map of fire, harvest, and succession. And again, let's do it for time steps 1, 20, and 40. And I can click Apply. And so here we have, along the top, the cells that transition according to fire. In the middle, the cells that transition according to harvest. And at the bottom, the cells that transition according to succession. And each column represents a different point in time, in this case being time steps 1, time step 20, and time step 40. As with the state classes, I can scroll through different iterations. And I can also make edits to the legend. So I could right-click on the fire legend and make my fire transitions appear as red and return to the map and select Apply. Now, another thing that jumps out is that the location where these transitions are happening is very random. In the next tutorial, I'll be showing you how to create patterns, spatial patterns, in the way transitions occur in the model.